All right, so range types and why I'm going to try to transform your life in the next 40 minutes. So what's a range? I think we're all pretty familiar with them. It could be a range of numbers. It could be a range of prices. Basically it's an ordered list that extends from point A to point B, and you know exactly how to get there. And it's something we see them all the time. When we're schedules, when you're working with probability applications, or just dealing with ordered data. It's something we're very familiar with, and we write queries for them every day. So currently, how do we deal with ranges? I think the best way is to explain through an example. So let's say, I'm running a company, and I have hourly workers, and I want to know when they're all coming into work, when they're clocking in, when they're clocking out. So I created this table, and you notice I have two columns, start time and end time, which are timestamps, because naturally someone might be working from 10 to 2 or 6 to 8. So if I want to figure out when someone is working, I could write a fairly straightforward SQL query. Employee 24 comes in. I want to see if right now at 10:30 a.m. if employee 24 is on the clock. So we know that the between and keywords enable you to find within the range of whatever you're setting it in. Let me try to explain that a bit better. So if you notice here, current time. If I'm seeing if the current time stamp is between the start time and the end time, that's the same thing as saying start time is less than or equal to current time stamp less than or equal to end time. Am I in the middle of the time range that I'm looking at? So naturally, we're going to get the correct result in that. Actually, one little caveat I'll give with between and, I love it because it's a shortcut, because normally you'll have to do, current timestamp greater than or equal to start time and current timestamp less than or equal to end time. But sometimes you want, you don't want that last time inclusive, particularly because, let's say you do from 2 p.m. to 3 p.m. If you do less than or equal to 3 p.m., you include everything at 3 p.m. as well, where you might actually just want up to 2:59, in 59 seconds. So that is one caveat. How about when can I actually schedule this employee's shift? I think it's pretty easy. I go to start doing it. I want to see if they already have their employee schedule set up. So I start writing the query, and I realize, wait a second, this is actually pretty complicated. I just created one part that could be overlapping in terms of a schedule conflict, but there's a lot more to that. And it's actually very easy to visualize. If I'm looking for when I'm actually overlapping in someone's schedule, there's 4 possible ways it could happen. It could either be it overlaps at one end, it overlaps at the other, it completely overlaps, or it's within the actual schedule itself. So there's a lot of things you need to check for, and the SQL for writing that is not fun nor straightforward. So right now in Postgres 9.1, or should I say last week in Postgres 9.1, was there a built-in function to determine if ranges overlap? Nope. But perhaps I could have created a composite type and added some logic around it and made it easier to do. No, still pretty complicated. Maybe I could use a different database software, and they support some sort of range functionality. And to the best of my knowledge, you can't. I looked extensively. So I started hoping perhaps there's someone smarter than me that can make my problem easy, because at the end of the day, I'm a big database geek, but the way I make money is by doing web development. So I don't have time to be futzing around with C, unfortunately. But it turns out in November of last year that yes, there were some very smart people who worked on range types, in particular one of them. And Magnus Hagander IM'd me the day it came out saying, look, you have range types. They've been committed. Patch your version of 9.1. I'm like, ha, 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 no. But I've basically been waiting for 9.2 to come out since then. So here's the cool thing. We have several built-in ranges that just, right off the bat, you load up Postgres 9.2, they're ready to go. We have int4 ranges, int8 ranges, numerical ranges, which is basically your set of real numbers. The last 2 are integers. Timestamps with time zones, and date ranges. And Jeff, I could imagine the pain you had just dealing with the time data. I mean, that is not fun at all. So let's go back to a pre-calculus, because one of the important things with dealing with range types is you need to be able to read range notation. So first of all, how many people are comfortable with math? Cool. That's why I love the database community. It's like, you just gotta know everything. So, I mean, I don't want to like read out all the different notations, one by one. But basically, you have a square bracket that's gonna be less than or equal to. You have a parenthetical that's gonna be a less than. So also know that we can have empty ranges too. So the other cool thing, I think this is particularly cool, is that we can have infinite ranges. I mean, that's pretty powerful, especially when you don't know when something's going to end, or you don't know when something's going to begin. But there is one little catch, and I'm going to try to explain this as best as I can without being too familiar with the internals. You can have infinite time ranges and date ranges, but there's a special keyword called infinity that you do not want to include in your ranges. Infinity has special meaning when you're dealing with a date and time manipulation. So just accept that for what it is, and accept that you can even run this right now in your 9.2 command prompt, and you'll see the first one is going to return true, the second one is going to return false. So how do we build a range? Well, let's use some Postgres syntax. It's pretty simple. I have a range from 1 to 10 inclusive. So, but you notice that when it outputs it on the command line, it's going to be 1 to 11 not inclusive. And the reason I heard for that was because if you want to look at ranges in a row, you can basically see the overlapping sequences as you go down and you look at them. Does it make sense? Yes? Yeah. It's one of those things, accept it for what it is as well. But I think it'll pay off. As you see more and more ranges put together, it will pay off. So, date ranges, nothing. No, I don't think I'm blowing anyone's mind here. Pretty easy. So, of course, complying with the SQL standard, you can use the normal constructor too. So, one thing to note is that the constructor defaults to arranged with a non-inclusive bound on the right side. Again, that's because of the display purposes, I'm guessing. Right, Jeff? Why it defaults? Okay. But you can easily adjust it in the constructor. In the last your last parameter, you can say, okay, I want an inclusive timestamp range. So, what sorts of operations do you get with dealing with ranges? Well, you have your normal equality operations. Are these ranges equal? Are they not equal? Is this range less than this other range? Is it greater than? Actually, I see one of these is wrong, but I mean I think you get the point that we have all these typical what I would expect when I'm dealing with if I was comparing 1 and 3. You're gonna get the same exact output, except we have an entire range. We don't have single numbers. But this is nothing too magical yet. It's like, sure, okay, we have ranges, but what can you actually do with them? This isn't. Why do I want to have this all in one column, one data type? Why, I can still do all these things with 2 columns. So let's use an example. Let's say you're trying to shop for a car. You have a budget. You go to some used car site, and you want to see what they have available. So first, we get to the site. Let's say we actually have access to their database because it's completely insecure, and they're running Postgres 9.2. We want to see, what, let's first order, in terms of, what is the price of the car? What is the cheapest possible deal I can get? So there's a function called lower, convenient name, that it'll take the lower bound of the range, and you can manipulate that. It returns an integer, date type, etc., whatever your primary data type is. So if you see the order, clearly, this makes sense. It's ordered by the lowest number. There's also an upper function, so you can manipulate the upper bound as well. So car shopping is should be easy, right? We know what our range is, and now we understand overlap. So, I mean, here's a concrete example of what an overlap would look like with some real numbers. So I know that I want to find something that should fit my range, should intersect with that red line. So our old method of writing the SQL, and this is actually the complicated way of doing it, is this works. This will find exactly the kind of car I want in my range. But imagine the pain it took me to figure out this was actually the correct query. There's actually, just another fun point. There's actually a shorter way of doing this. So this query assumes that it checks for everything that's touching the red line. But you can actually do the opposite and say, OK, find everything that's not touching the red line. And once I know that, I know everything that is touching the red line. And actually halves this query. You just add a not to it. So, I don't like doing that anymore, especially since I have the real power of range types at my disposal. So, as you see here, we're going to introduce a new operator called the and, which means overlaps. So using my range constructor, I can now say, all right, whatever the car's price range is, let me and that with my actual budget, and lo and behold, I have everything that overlaps with it. I mean, so we've basically taken this monster and compressed it to one line, which I don't know about you, I like writing less code because it's less things that I can break. So, I explained this already. All right, so we get the point of this. All right, so let's say, I want to save some money on my car shopping. I know what the lower end of my range is. I want to find everything that's like outside of my range, but like, really cheap. I want to see what the real bargains are. That's where we have the less than operator. I mean, it looks like a bitwise shift, but this is actually finding everything that's like completely out of my range, completely below what I'm looking for. And sure enough, the logic holds. Everything that's outputted is less than my range. Now let's say I want to look at the really cheap cars, the things that are heavily discounted. I'm sorry, Bruce. It should, yeah, that sounds like it's the same. I think the difference is that this is one less step, and we're going to talk about indexing a few slides from now, and you basically get the benefits of the gist index from using this operator. So that said, here's another new operator. So I want to see not only like the bargains, but I want to see things that are within my price range. So basically, this does a partial, overlap and everything below what's overlapping in my current range. So again, as we look through the list, the logic holds on that. So let's say, I'm dreaming of, owning a Lamborghini. I want to see things that are, completely out of my budget, to see what I can actually save towards. If, when I'm programming my website, the range type code works so efficiently that we make enough money I can afford one of these things. So that's where we have the greater than operator, which does exactly that. So this one just, this is sort of a contrived example, but the idea is that you can also do range intersections. So basically, I mean, we're familiar with intersections just from set theory. It's, what's actually completely overlapping in, this, the finite window I'm looking at. So in this case, I guess the example I gave is, I have like a limited negotiating window, and, I want to find things that, which cars are actually, what prices can I actually look at, within my intersection. Is everyone with me? I don't know. I don't think I'm explaining that one very well. Okay, so let me back up. So when I'm intersecting two ranges, I'm finding the exact overlap between them. So let's say I have a range of 1 to 3 and a range of 2 to 4, and I do an intersection. The output of that's going to be 2 to 3. Is that good? All right. So essentially, I'm trying to do this now with my car shopping. That, all right, there's a bunch of cars. My price range is, 13,000 to 15,000. What can I actually, negotiate with based on their car inventory? So I perform that intersection, and I know that, okay, if I want to get the Lincoln Continental, I'm between 13,000 and 14,000, based on the intersection. I think in a real-world negotiation, you would never do that. But again, this is why it's fictional. But yeah, do we feel good about intersections now? Okay. So this is all fun and good, but are they quick? In the sure. Um, yes. Correct. You're welcome. All right, so are these fast? In the web world, you care about speed. I also think you care about speed in every other area of software development. But yeah, when I run and explain, on my simple data set, okay, it's doing sequential scan. I mean, if I only have 10 cars in my inventory, that's fine. But what if I have 100,000? And what if I have 100 people searching it per second? Things are going to be really bogged down. So the cool thing about range types is that they support gist indexing. So gist indices, if you're not familiar with them, basically allow you to extend operations that are defined, basically new operations, and allow you to get the full power of the Postgres indexing engine. So the great thing about the range types is because it does interface with the gist index, that we can actually run these very fast queries against our range types. So if I expanded my my car data set, and I forget how many I added. I think it was 100,000. And sure enough, when I tried to run the same query and I ran the explain on it, I actually do hit the index, and I do get a really fast result. So let's go to another real-world application, which is scheduling. How many people have had to write scheduling applications before? How many of you had to deal with double booking? How many of you have had to deal with just all the other nightmares associated with scheduling, just like things not working? Yeah. All right. So the nice thing is, we could try using unique let me back up a second. In the old world, we could try using exclusion constraints, unique constraints, but almost to no avail because we didn't really have that full overlap functionality in order to properly, for instance, book a room. So now let's use an exclusion constraint without the overlap operator on our range. So I'm going to insert a few values. Bear with me. So I have one trip between the 7th and the 9th, one trip between the 12th and the 17th. And then I try to book one from the 16th to the 18th, which overlaps with the one from the 12th to the 17th. And lo and behold, I get a warning saying, you can't do that. You're already traveling. You can't be in two places at once. Yes? Yes, because it's, I think, correct me if I'm wrong, the default would be equals. If you're doing an exclusion, no, I think no, with an exclusion constraint, you need to define your operator, regardless. Yeah. So, yeah, so in this case, I'm choosing the overlap operator because, I want to make sure I don't conflict, I can't be in two places at once in this scenario. All right, so does everyone follow that? So when you define an exclusion constraint, you got to make sure you include which operator you're excluding on, or function, or whatever choice you make. So anyway, so the nice thing is, at the database level, as opposed to at the application level, you can prevent bad data from being written. You can make sure that you don't have, overlapping, double-booked rooms, airplanes, you name it, from occurring. Airplane seats, I should say. So this is pretty easy. Now, I'm just going to speak for a second from the real world. So I have an application I'm going to talk about in a bit where, it involves room booking. And as much as I want to use this feature to prevent, bad data from getting to the database, I may not be able to because there are instances where my clients are going to want to double book things for various reasons. So it's sort of like, every cloud has a silver lining, or in this case, every silver lining has a cloud. I really want to use this feature. Maybe I'll come up with a way of how I organize the columns so I can still, exclude, I guess, in a hacked way and make sure, there's not too much bad data written into it. But, it's sort of like at the end of the day, you're beholden to your clients. So, as a typical traveling salesperson, this is not all. Ranges can be extended. So we have several built-in types already, but it's actually pretty easy to add some more. So actually, I was kind of fascinated that IP address ranges, INET ranges were not automatically included because I figured, well, that's a really obvious use of ranges. I want to see if let's say I'm a DHCP a server. I want to make sure there's no conflicts within my range. I think that's how it works. But lo and behold, I can just use the create type functionality and indicate that's a range and choose the subtype. So lo and behold, here's another operator. I want to see, is this IP address within a particular range? So the less than and ampersand that means am I included in this? So sure enough, if you look at the range values, one of them is in it, one of them isn't. But basically, I just completely extended the functionality with one line of SQL. That's pretty cool. So the subtype is specific to create type. And this is actually, so the reason I like this example is that this is a really easy one. To actually extend some other things to ranges, you might need to do some more work, which will involve writing custom functions. This is actually explained in the documentation, and I was going to make the excuse that I don't have time to go into it, but I think I'll have plenty of time to go into it. And so I'll use the other excuse, which is I'm not too familiar how to do it. It's a little bit more complicated, but the good thing, it's sort of like using the gist indices, that they're there. You can basically index anything, but you need to understand it, and understanding it is half the battle. So, range types in the wild. This is sort of to be happening, within the next couple of weeks. But so the company I work for, VenueBook, the main premise is that we're booking venues, we're booking spaces. You have a party, we need to book it. Now, there's a lot of fun part in that. There's not only room reservation, but first you also got to find what kind of venue you want to book. And what does that involve? That involves having a number of guests, involves having data availability, and it involves having a budget. So in the niceness of a user interface, we've actually encapsulated, you only need to put in one number. I have 40 guests, I have a budget of $2,000. But behind the scenes, it's actually a range because not everything fits nicely in a box like that. So what I actually do, in the search I currently do with Postgres 9.1, I use that very long query I showed you earlier, modified ad hoc to the purposes of my search. But now with range types, I can basically say, all right, $2,000. Maybe they want to see something between 1,000 and 3,000. All right, map that to a range type. I have I have budget ranges for all my venues and range types. I do an overlap operator. It returns quickly. Done. I basically saved, days of programming and put it, maybe not days, but, hours and hours of programming, and, I brought it down to maybe, 30-minute exercise, which includes proper testing and making sure the users get the results they want. So this is cool. This is going to be live within the next month, using this brand new feature, and I invite you all to try and break it and see, test my programming. So, for more information, there is a lot of documentation. So the first one basically explains how the range data type works. The second one explains all the functions. The third one is for extending the range types, which is basically from the create type documentation, and explains to you what I can't explain right now in words, which is how do you actually extend a range type that's a bit more complicated than an IP address. And finally, there's a wiki, which I think is still, I think it basically explains the process to which the range types are developed and what they're used for. I had that link up there because I was actually giving this talk before range types before Postgres 9.2 came out. So, in conclusion, like I said, it's actually not that long a talk, once you get down to it. But, if you're not completely smitten by these things, then I'm sorry, I failed at explaining them because I think they're revolutionary. And I hope you do too, because, once you do come across a problem that involves a range, you're gonna be like, oh, great, thank you. There's so many, easy, functions available just to figure out, how to solve this problem. And of course, if you haven't upgraded to Postgres 9.2, you need to do that to use this feature. So, upgrade soon. I know there's a bug. I think some people might say it's a bad bug that's being fixed. I think Monday, or it's gonna go up on Monday. Yes, core team. Okay. So, oh really? Oh, okay. So. Keep an eye out for, so make sure the next release that comes out, which should be by Monday, upgrade your 9.1s and your 9.2s to the latest release. So thanks, Jeff. Personally, I've been eagerly anticipating this feature, but Jeff authored this. So I would, honestly, I would thank him for this, with applause. It's pretty cool. And also thanks to Alexander Korotkov for the gist improvements, which allow us to have these really fast searches. So if you have any questions, want to throw things at me, etc., this is my contact info. And yeah, let's start. Sure.
There's a school of thought in numerical analysis that says individual data points should be represented with ranges. And I'm just wondering, and that's, in other words, you have an interval of a sample interval. You don't really know anything at a particular point. You just kind of know it happened within this window. Mm-hmm. And you can just rewrite all the rules, all the algorithms in numerical analysis using this. I'm wondering if you think the range types could handle kind of that higher level of query. Give us an idea of the volume, because you get a lot of complexity in the overlapping relationships with things, and especially with the exclusion. Can you handle tens of millions of, say, sample points that are represented as ranges? So I know it started at this point in time and ended at this point in time, but I don't know exactly where, so I just represent the sample as a range instead of an individual point in time.
Okay, how specifically are you querying inside them? Do you care about what's inside it at all, or do you just care about, the bound? I have a range that's this big, and I have, bounds, at these ends.
Well, I'm just kind of brainstorming here. I'm just saying, give us an idea of the kind of volume you think. Have you done any prototyping with, say, tens of millions of overlapping intervals?
So I haven't worked on anything to that scale. You can ask Jeff, because I'm sure Jeff has done some serious benchmarking. All right, so just to repeat for the mic, the long story short is that it depends on the types of queries and the types of problem that you're solving. If it's more complicated, you need to evaluate what types, basically what you're trying to get out of it, and base your queries on that. I think just to speak from a pure volume perspective, Postgres, if you use Postgres right, it is very scalable. To use our favorite buzzword. And it's really, how it's basically, how do you use your indices? How do you, what hardware are you actually running Postgres on, et cetera. How do you break up your table? How do you break up your data?
Hi, I'm interested in the performance comparison using the range types to what you would use previously. You would have 2 columns, and you would have an index on each. So you wrote this website, and you had prior versions. I assume that you have like some performance comparison.
All right, so I haven't fully implemented range types in the current version of the website. My expectation is that it should be more efficient, just in terms of, if I just think of it from an I/O perspective. If I have, let's say I have 1 index as opposed to 2 when I'm doing my lookups, I only have to go through one index tree. So my read should be faster as a result of that. Of course, you would say, well, there's underlying logic too. There's more underlying logic with a range type than necessarily with MySQL, but at the end of the day, in some ways it's equivalent. I'm doing, in my overlap, I think it's like 19 operations in my current implementation. And while I'm only doing 1 operation technically when I'm doing a range type overlap, I'm still, that operator is encapsulating a lot of logic there. I would actually love to do a follow-up to this talk, which is, all right, I've run them in the wild. Let's see how it goes. And perhaps that'll be something like I'll tweet out, I'll blog about, I'll find some way of communicating, the full result of it. But I'll just say, just from my early experimentations, I did put in some serious data, and it returned pretty quickly. And it returned just as fast, if not faster, than the old method. Thank you.
So I have a lot of data where there's sort of a begin and an end. And my first inclination is to think, hey, I'll just make those a range type. Is there any reason why I don't want to use that in those kinds of circumstances? I feel like these are all sort of the same question you're
Sure.
getting. But
okay, and I think that's a good question. And by the way, if people want to chime in, feel free. I like, one of the things I love doing when I give talks is just turning them into a discussion, especially when it's new features. So I'll give you reasons why not to use range types. So this is a good example. Let's say I really only care about the beginning and the end of my range, and I don't care about stuff in between. Well, if I'm constantly accessing the beginning and the end, I'm going to have to use the lower and the upper function, which means I have to pay a penalty from calling a function. So if I'm doing queries over that constantly, well, then I probably have to write it, I would want a functional index on that, which then I have to pay the penalty of creating a functional index and, maintaining that. And, when I say maintaining, basically Postgres maintaining the updates, the deletes, the inserts, et cetera. So in that case, maybe I would prefer to use 2 columns. It just, ultimately I would have to benchmark it to see what would happen. But I feel like if I'm not using, any of the range type operators, I probably don't need range types in that regard.
Is there an overlap with the PostGIS operators doing the same thing for geographic ranges? It's inclusion, exclusion, point and range, that type of thing. Are the operators the same overloaded operators?
That is a good question. I don't know off the top of my head. I think, the one thing I think the Postgres community has tried to do is keep the operators standard, so that, when you have different data types that, for instance, the less than at sign, which is the include, basically, am I included in this range? I know that's the same as a point being included in a region. Or, basically the geometric types in Postgres, it's the same exact things. Like, is this square included in this square? To that specific question, I would have to look it up. But, yeah, I don't want to give you the wrong information.
Have you had to deal with tables with time ranges that are being time partitioned?
Yes, once upon a time, when I had to deal with TV schedule data. This was, I think, what version of Postgres was it? It might have been 8.1 or 8.2.
So how did you deal with the partitioning and the ranges?
Okay, so it was actually, I would say it was actually a very messy solution, given the tools we had at the time. So for one thing, when we did the table partitioning, we used, basically, there's, let's call it a formula or an algorithm for setting up table partitioning. We followed the formula and said, okay, we want our TV schedule data for August to be in this table, using all the rules and basically the method of setting up partitioning. So we want August here, we want September here, we want October here. The long story short was that it was messy because we constantly had to keep creating new tables, new rules, updating the database. And the other thing, has anyone ever played like the Tribune Media Services data or like TV data? Okay, so it changes constantly. You basically get a 2-week snapshot of everything coming up on TV, and anything in those 2 weeks can change. So you have to get it every day, re-update it, and it's like a long, painful process. So why am I saying that? Because not only are we dealing with messy data coming in, but we have to maintain this messy schema in order to partition it. So I guess to get at what Josh is getting at, can range types make this problem easier? I think in terms of the overlap, absolutely. I think the nice thing about, let's say for the instance of TV data, is that things are going to run on we were basically doing it by month, so we could segment it by date. And like a date range is much easier to deal with than a time range. Because if you think about it, a date range is discrete. You have, it's the 17th, the 18th, the 19th. Time is continuous. I mean, which sounds, like some sort of transcendental thing, but it's going on, and you don't really have breakpoints in it. So part of your partitioning strategy should be first you should ask yourself, what is the easiest way to partition? Like, do I absolutely have to partition by time? Because there's a lot of cases where you don't have to. You could find, perhaps you can do it by your primary key. Perhaps you can do it by, some other, an enumerated type in your database. But there's some times, like with, TV data, that you might have to do it by time. If our database at that, when I was working on that database, it wasn't too large. It was, I forget how many gigabytes. So let's say 50 gigabytes. So it was still manageable. But if I stayed in that business, perhaps I would be dealing with 4 terabytes of data by now, and that strategy I don't think would work so well. And I might actually have to say, like, okay, we need to have a partition today just for Tuesday the 18th. I think and then I definitely see range types being much more, in fact, imperative to use in that case.
Okay.
I love how questions beget more questions. This is what's great. This is also why I love this talk, because it is a very short talk, but suddenly it's like.
Yeah. So I waited till nobody was at the microphone, so I obviously overused my quota during the thing, but obviously now I have a whole bunch of questions. So that's
right.
what it's like.
Let's go.
So last week I gave a talk about the 9.2 features to the Philly user group. And Josh Burkus did the same thing for San Francisco.
And in a month, you'll be doing it in New York.
And I'll be doing it in New York. And when we got to range types as a feature, the only thing I could say was Michael Glazman, who was in the audience, is super excited about them. But I don't understand them well enough. So all I know is they're tremendously exciting. And once I understand them, I know I'll be excited. But right now, I have to take Glazman's word for it, right? And what I got from this talk was actually kind of pulling the covers away from something that is super powerful, as you said. I mean, you had it up there. You said, if you're not excited about this feature, I didn't explain it, right?
Like, and seriously, like I will like hang my head in shame.
Right, because like other things we've brought in, like full text search and writable CTs and like window functions, it's sort of a, to use your word, transcendental type of change to the way you think of things. And it takes a while to really wrap your head, or it needs a presentation to really wrap your head around it. I know I didn't understand full text search until I heard Oleg and Theodore give a presentation at PG Open about full text search. And before then, I was just completely lost about what this thing was. But 40 minutes of them explaining it in Russian English was enough for me to get it, and then I was able to kind of embrace it and understand where it was going. And this is really what this did for me. So I guess my first question is, are the slides available online? Was that
Yes.
one of the web things you had up? Or?
Mm-hmm. Yes,
Okay.
I'll tweet it out.
Okay.
Or, as well.
The second thing was when you had your slide up about the application you're writing, and you talked about the cost being a range. Well, I guess also the number of attendees is a range too, which I hadn't really realized, but it's a range because the room will take between 20 and 50, and you're not going to put 5 people in a room for 5,000. So there's kind of a logical range. So I'm starting to see more ranges, I guess, and you're probably doing that too. You now see ranges that you didn't see before. In fact, even when this gentleman was talking about measurements, usually, I think as you were really implying, measurements are really not discrete. When something's 72 degrees, it's really not 72 degrees, right? It's 70 degrees plus and minus whatever the precision is of that instrument. And the idea that we can now express that in the database and now do queries without sort of artificially mucking up what we're doing, which is usually the way we usually do it, really brings a whole new, aside from scheduling, in terms of measurement, it also brings a whole new thing. So I'm starting to now see the light of why this is so exciting. That I didn't really understand. I know it's wonderful, but I hadn't really gotten it, until this, and really sort of see how it changes the way we think about problems in a way that I hadn't,
The question is, can now we scale it up to a couple hundred million real quick? I can give it that data real quick. There's a lot of problems where you sample it. You don't know, you just know a boundary. That's a real common model, and you artificially create, the inhabitants of that boundary. That's just a lot.
Yep.
This just happens in some range.
Yep. And I think with the performance, basically the performance enhancements on the range types, the indexing should definitely help with that. And just using a lot of the features in like 9.2 were focused on performance. Like, I know one of the big things being promoted is that you can run Postgres on 64 cores now and get, I think, 300,000 transactions per second. So we have that level of computational power to deal with tens of millions of rows just on a single node. I know even in, for instance, in the pharmaceutical world, when you're just, taking measurements on, if you're doing a clinical trial and you're taking measurements, there's always an error bound in that. So basically, you could have your measurement and essentially know the range outside of it. That it could be, within this window, and it'd be interesting to see, what applications, you could derive, from using this feature, and that, if it helps.
Yeah, I mean, the way you usually fix the range problem is when you do your query, instead of checking for 72, you check for 71.5 to 72.5. So your constant ends up moving around, but that assumes that all the values in that column have the same variability, right? The same precision, which is not true, right? Because you might be measuring one thing with one instrument that has one precision than something else with another that has a different range of precision. That's impossible to do without range types, because there's no way to represent the range unless you add a precision as a separate column and try and work that into some very complicated, something. And the other thing is that Alexander Karkov he's been really he's been attending a lot of our conferences. I know he's probably be in Prague, but he was in Amsterdam last year, and he's been working very hard on performance. So we do have somebody who's really got his head in this from performance angle. So if there's anything that isn't working fast, I think we have at least a resource to go to.
Yep.
So thank you.
Thank you. So just 2 quick comments on what Bruce said, the one of them I just forgot. The writable CTEs, by the way, which is one of the features he mentioned, it's actually amazing. Like, I had a really messy delete I needed where I need to, like, figure out the data in like multiple tables and then put it into in the delete. And of course, the delete syntax is kind of hard to deal with like joins and, in order to delete your data accurately, because of course you can only delete from, one table at a time. But with a writable CTE, you can actually delete from multiple tables at a time and then get to your final delete. So for instance, if you have, foreign keys, and, of course, you're dependent on, data, I guess, data being in its appropriate place before deleting it. With a writable CTE, you can just like do a cascading delete, which is pretty cool. Or you can always do like, I think, there's no, is there delete cascade? I know there's a truncate cascade, which like you should never run unless you know what you're doing. You can suddenly like, for those of you who don't know what that is, truncate is a way to quickly delete a table. And truncate cascade is a really quick way to delete your entire database if you're not careful. So yeah, I think, any more questions? We have a few more minutes.
I'll try and make it quick.
Sure.
So you were talking about where not to use range types, and typically it'd be situations where you've got the beginning and the end already modeled. And you mentioned you were migrating. Have you played around with actually having your beginning and end defined as columns and then using a function to build your range type on top of existing data?
So actually, I'm going to answer this in an interesting way. So, a lot of the work I have to do, so, I program in Python. So at the end of the day, I need to map, whatever I do in the database, I need to make sure I map it to like a native Python type, at least for the ease of use for, the rest of my developers, which right now is, 80% of the time me. So in that regard, I actually do have some mapping between, my Python types and Python ranges. So when I do the migration, when I actually run the full migration for the database, I mean, what I'll do, it's probably gonna be fairly non-trivial. It'll just be something like, I'll just take the two columns and then plug them into the range type constructor and add it that way.
So for the stuff you're doing, you wouldn't necessarily need both.
No, in fact, I'm gonna have both in the beginning, just as my backup.
Right.
I think I'll gradually phase that out.
But so you're doing that through code to migrate from one to the other as opposed to
and then I'll probably just, whenever I insert data, I'll probably, as opposed to inserting to my two, let's say my two budget columns and my one range type, instead of an either or, I'll just insert to all three.
Right.
And then when I'm ready to like completely axe the other two, I'll do it. The nice thing about having a relatively low load is that you can mess around with things like that and see what actually works.
Thank you.
Low production load. Oh, so the other thing I'd like to mention, and we have 1 minute. I don't think Jeff can explain this in a minute, but Jeff, a question for you. So when I took math, I learned that when you're dealing with real numbers or I guess numeric types, that you don't know how many numbers are in between two real numbers. It's just mathematically impossible. So I'm curious, how hard was it to like deal with numeric types and time series and just deal with infinite ranges? Yeah, please. Sorry, this is like my personal fascination. I hope you don't mind.
So conceptually, it kind of took a while to work through the details between what I call discrete ranges and continuous ranges, which are discrete ranges are things like integers, right? So there's, if you have a range of integers and the bounds are finite, then you have a finite number of points. But that, like you said, is not true for numeric. So it took me a while to come up with some kind of way to reconcile those two in a way that makes sense. What we ultimately came up with was, kind of a concept of, a function that's associated with the range type that can kind of canonicalize it. And so with like an integer range, open open 1 to open 10 is the same as close 2 to close 9. But that's not true for numeric. So through this kind of what I call the canonicalization function, we were able to kind of reconcile that. And that was after quite a bit of discussion in the community.
Cool. All right, so I think we're out of time. Thank you. If you have any questions, please feel free to ask. there will be.